Hello everybody! Happy Valentine's Day Eve! Boys, remember to bring your ladies flowers tomorrow. Bring them kisses. Okay, this is the next section, Law of Cosines, and we're going to do two examples. There's your homework there. I'll start off with the definition, and I'll show you guys the proof without talking about it. You guys are welcome to pause and digest that screen, or you can move along. Let's go ahead and get started. The law of cosines is for situations where you are given a triangle that has SAS or SSS, and you need to figure out the remaining sides and angles of the triangle. You can use the law of cosines, which are these formulas here. And it seems like a lot at first, but it's really pretty easy to remember. So let's get to it. So this is the start of the proof for the law of cosines, and so basically it starts with a triangle and create two triangles in the triangle, and we write x and y in terms of sine and cosine, and basically what we do is we use the distance formula with x and y in terms of sine and cosine to come up with the law of cosines. And you guys were welcome to pause or just move along. So here we have a situation where we have an SAS triangle. We have a side and then an angle, and then we have a side. And what that means is, with that given information, we can figure out what A is equal to, what little a is equal to, the side opposite of the angle that has been given to us. And I'm going to go ahead and use the formula down below, and you guys can follow along using that formula. So we have a to the power 2 is equal to one side to the power 2 plus another side to the power 2. And here I am not even using that formula. I'll use that formula. We have one side to the power 2 plus another side to the power 2 minus 2 times one side times the other side times the cosine of the angle in between those two sides, which is 60. Okay, so let's go ahead and crank this one out. We got 20 times 20 and 30 times 30 and 600 times 2, and the cosine of 60 is equal to 1/2. So we have a squared is equal to 1300 minus 1200 cut in half is 600, which means we have a equals the square root of 700. And of course we just take the positive because there's no such thing as a negative distance. And so from here I got 700 giving me square root of 700 approximately equal to 26.5. So we have little a here. Well, that's a bad squiggly. There we go. 26.5. And now that we have 26.5, we can use the law of sines to come up with the other angles. For instance, if I wanted to find out what angle B is equal to, I could say that the sine of B over 20 is equal to the sine of 60 over 26.5, and then from here we would multiply both sides by 20, and so that gives us the sine of B is equal to 20 times the sine of 60 over 26.5. And from here, we would do the inverse sine. And the inverse sine, taking the inverse sine of this particular ratio, will give us the B value. So, in other words, we will have B equal the inverse sine of this particular ratio. Now, if you all understood the previous section on the law of sines, then I don't see any reason to go through with the rest of this problem. So, let's move on to the next one and not waste any more of your time. Example 2. So example 2, we're given an SSS triangle, which means we're given all sides of the triangle, and based on that, we can use the law of sines to come up with the angle. In this case, based on this formula that we have here, I'm going to solve for the cosine of A, and then eventually just solve for angle A. You could solve for B or C if you wanted to. I'm just using this particular formula, so I'm going to solve for A. Before I do that, I'm going to go ahead and solve, before I start plugging in the sides, I'm going to solve for A right now. So we start off by subtracting B squared to both sides, and C squared to both sides, and what that gives us is A squared minus B squared minus C squared is equal to negative 2BC times the cosine of angle A. And so from here we have to divide both sides by negative 2BC. And that gives us what the cosine of angle A is equal to. These two cross off. So we have cosine of angle A. And let's go ahead and solve our triangle based on this info so far. Okay, finally, let's start plugging away. So we have A, which is 6, and we have B, which is equal to 9, and we have C, which is 4, over, we have B, which is 9, times C, which is 4, and that's equal to the cosine of angle A. So I'm going to go ahead and erase this. Too much blue on my screen. Pull this up a little bit more. And let's use our calculator to figure out what that ratio is. So unfortunately you guys can't see what I'm typing in my calculator, but you'll get plenty of practice in the class. You got 6 power 2 minus 9 power 2 minus 4 power 2. And I'm getting a negative 61, and then we divide that by negative 2 times 9 times 4, and I'm getting that the cosine of A is, I should write approximately because it is an approximation, 0.8472 with a line over it, which means that we're going to do the inverse cosine of that particular ratio, which is represented as the decimal now, and that's equal to A, aka 32.1. I'm rounding to one decimal spot. So we got A is equal to 32.1. Now, at this point, it's up to you really. You can choose to use the law of sines to continue and solve for the other angles, or you can simply use the law of cosines to solve for the other angles. It's up to you. And I'm going to go ahead and end it here at a little over 10 minutes. I'm looking forward to our time together tomorrow. Happy Valentine's Day in advance.